Good morning, good afternoon, or good evening. This video is, I'm creating this video to help you study for your Chapter 5 makeup test. And I think the best way to start this is in Student View, which I thought I had up already. Yep, here it is. And so I'm in my Student View, and I've come up here and I've clicked on my 3 bars to get my menu, and I've come down to Review. And I never know where it's going to land me when I click on Review, nor does it actually tell me the chapter and section that I'm in. It tells me the title of the section or topic, I suppose. So what you need to do is click on this drop-down little tab here, and then you can click on this drop-down in order to access the menu and determine exactly where you are in your review process. And I'm going to start in 5.1. So now that I've selected 5.1 and I click on this first tile for rational expressions, I see something that looks a lot like one of my previous homework problems, or maybe an exact homework problem, and the request here is to simplify. So what I'm going to do in this video is I'm going to go through and I'm going to look at some example problems that we see from these various topics. I'm also going to then talk about how do I prepare for or study that particular topic. And one of the sort of parts of that process is going to be accessing my YouTube channel as an option. Okay, you don't have to do that, but based on the fact that you possibly scored lower on your Chapter 5 test than you would have liked to, maybe you want to consider using my YouTube channel this time if you didn't previously. And the other thing that you might want to do is take a look at the ebook. And so we'll dip into the ebook in this video also. So let me go back into this tab. So I'm looking at this problem. In order to simplify a fraction, and let me actually jump to an example problem that's in another topic within this section. It's actually a pretty similar topic. The request here is the same, is to simplify. And here, to simplify this fraction is, I think, pretty easy. Look, here's a 3y minus 8, and here's a 3y minus 8, and those 3y minus 8s would cancel. You could just draw a line through those if you were taking some notes on this video. You could write this problem down, put a line through those are gone. But notice that the 40 divided by 5 can also be simplified. And you should do that, and if you're taking notes on this particular problem, in addition to writing down this problem, and after you cancel the 3y minus 8s, you might also want to rewrite the number 40 as 8 times 5. And then you can see the 5 from the numerator and the 5 from the denominator also cancel out, leaving you just with an 8 in the numerator and this y minus 6. In the denominator, the 5 will be gone, and the y plus 4 will still be there. And you could type that in as your answer. You don't even have to distribute the multiplication by 8 into this binomial, although you could, and that should be equivalent to the correct answer. These little sub-instructions here say that you can leave the numerator and denominator for your answer in factored form. So again, you don't have to distribute to type that in, but you can because it says that you may, not that you must, leave them in factored form. So this problem and this idea of simplifying a fraction is pretty easy when it's already factored or broken up into these pieces that are being multiplied together, and you can start crossing stuff out, and when it's numbers, doing the division is typically pretty straightforward. However, in this earlier problem, this numerator is not in factored form, nor is this denominator, and so we need to be able to factor this numerator, which is a trinomial, T-R-I, trinomial, because there are 3 terms. We call it a trinomial. In this denominator, it's a binomial because there are 2 terms. And this denominator is a little unusual because the constant value comes first, the 80, and the term that contains the variable comes second. Usually we see the variable, in this case in the numerator, to the second power, and then to the first power, and then to the 0th power, which is just the constant term. So this denominator looks a little bit like it's out of order. You can change the order of these two terms, swapping them around this minus sign, if you rewrite this denominator as, and I'm not using my iPad or my digital pen and writing all this out for you, so if you want to write this down, I would recommend it. You can rewrite this denominator as negative, and then open a parenthesis. Oh, actually, I think I can type it in here. Nice. You can rewrite just the denominator as negative 5w squared minus 80. Notice that the order of these two terms has switched from the order that they originally appeared, but in order to do that, I had to factor out a negative, or a -1. Now, there's more that we could factor out of this expression. 5w squared and 80 are both divisible by 5, so I could have taken out 5 also, which means that I would need to remove this 5, and 80 divided by 5 is equal to 16. We've done a little bit of factoring, and what we just did there was we factored out the common the common factor in our denominator. There's additional factoring that can be done here. W squared is a perfect square, and 16 is a perfect square. It's 4 squared. And there's a minus sign here, which means we're finding the difference of these two terms, so this is a difference of squares. A squared minus b squared. I need to know, well, I already know, you need to know how to factor a difference of squares. And that was one of the topics that was on the to-do list that I gave you. So let's figure out how to factor a difference of squares. I'm going to, you know what, I think let's start in the ebook. Can I get to the ebook? Where did it go? I thought I had it open as an additional window here, but it's not appearing there. So let's see if we can get to it. I have a duplicate tab set up here. And now I'm not doing this in student view anymore. Oh, you know what? Staying in student view, I should be able to go over here to the ebook. Can I click on this? For some reason not. I think it's because I'm recording this video. You should be able to go over and click on that little button in order to get to the ebook. I am going to have to bounce back through here, and I'm going to get rid of my face, if I can. There we go. And you might start looking, because we're in chapter 5, you might start looking here to see about factoring, but in fact, factoring was what we talked about predominantly in the previous chapter. So I'm in chapter 4 and I'm looking for a difference of squares. Also, I'm looking for it because it was on my to-do list, and it's not jumping out at me. I see factoring trinomials, I see factoring binomials, and a difference of squares is a binomial, so it might be in there, and it is, but the other way that you could find it is coming up here, searching for difference of squares. And look, this first link is to factoring binomials. Inside of here, difference of squares. Okay, I think that's where I need to go. So I could get there by clicking on this link right here, or I'm going to go back into my table of contents. I wish there were just a back button. No, that's all right. So we could, staying in this list of search results, I can just click on factoring binomials. The other place that I could have gotten to that is you just saw me go into the table of contents. I clicked on chapter 4. This is the first page of the chapter 4. First page of chapter 4 in the printed book, and it appears identically here in the ebook. And then I can click on factoring binomials, so that's chapter 4, section 7. And sure enough, the first subsection is difference of squares, and we're already there. And as I mentioned, a squared minus b squared, you're seeing it here, you're seeing it here. This is the sort of template or the pattern for factoring. We've talked about those kinds of things in class. And here's an example. 16 is a perfect square. It's 4 squared. X squared is a perfect square. 9 is a perfect square. And the solution process goes on to rewrite those as a squared minus b squared. So the a value is the 4x and the b value is the 3. And they write that out for you over here, even telling you that the a is 4x and b is 3. So the ebook, if you can bring yourself to take the time to read this and to find the things that you need, this is very, very well laid out for you with these usually pretty decent explanations here. These explanations can get a little mathy. I try to present them when possible in even plainer English, but another resource for you. There is a practice problem for you here, and if you want the answer, all you have to do is hover your cursor over this. It's not giving you a solution process, but at least it's giving you an answer. Here's another difference of squares problem. This one looks a little bit more involved, and it is because there's an initial step of needing to factor out a greatest common factor. Needing to factor out a greatest common factor first. Hey, that's what we did in this problem. So you can see how this is how I learned math, by the way. I'm pretty good at it now, so if it worked for me, it can work for you, but it takes time. I've gone into my book and I found a problem that has an element that's pretty similar to the elements of the problem that I'm working on currently, and then I'm going to try to mimic that process. Oops, that didn't work. There it is. So again, factoring out the GCF, which is 2D, and then we're left with the rest of these, this information or this expression inside these parentheses here. No, that's a little small, sorry. And then we can rewrite that as, or in the form, a squared minus b squared, so that it's a difference of squares. And I just noticed actually there's a typo here. After the c squared, after the c, before the square, there should be a parenthesis. This should say open parenthesis, 7c, close parenthesis, and then the square, which helps us to identify, just like they've got the 5D. Well, this is wrong too. This square should be outside the parenthesis. They should really pay me more for looking at this stuff. So I found 2 typos in one line, so that our a value is 7c and our b value is 5d. And then we just drop those values into the format or into the template for the factored version of a difference of squares. And so on. So that's how you can use the ebook. Another example problem, this one does have a common factor that can be taken out first, a GCF, and you can hover to find the answer. And then look at this, there's even a hyperlink to a video provided by the publisher about factoring a difference of squares. So there's that video. There's also my video. Now, somebody told me recently that the order or the titling of these videos is out of sync with our ebook. I haven't gone back to investigate all of the chapters and sections, but I did double check these titles against these titles, and I think if you look through them, you'll find that they match up quite well. I did try to shorten these titles a little bit, so I've abbreviated some stuff, but otherwise they match up pretty well, and factoring binomials is one of the videos. So I'm clicking on this one, and I definitely don't want to watch me, and you'll find that some of my videos do have timestamps and some of them don't. This one unfortunately does not, so you can't jump right to an example of factoring a difference of squares. But what you can do is you can just kind of scroll through here and, hey, difference of squares, there we go. Here's a difference of squares that doesn't have a GCF. There's the a squared minus b squared equals a plus b times a minus b. Here's an example of a problem that has fractions in it. Here's a problem, this one's going to involve substitution. Look at these exponents, power of 8 and power of 2, yikes. So, and then there's an example of difference of squares in grouping. So it's mixing that with factoring by grouping. So this is another resource that you can use to see some additional example problems. In case you don't ever do this, you can go into settings. Excuse me. This is the first speaking of the day that I'm doing, so my voice is still getting warmed up. But you can change the playback speed, and you could watch this video at like 1.5 speed so that it doesn't take you quite as long to watch the videos, because mine can get quite lengthy. And then you can pause and slow it back down to normal speed if you want to hear it, where I sound less like a chipmunk. So that's just on this one topic, if I can get back to it, of solving this one problem. And that's just the denominator of this problem, factoring out a GCF and then factoring a difference of squares. In the numerator, this is a trinomial. So I'm going to come back into the ebook and see if, hey, factoring trinomials, 4.6. I've clicked on 4.6. And here's the AC method is the first subtopic within that section of that chapter. The AC method was on your to-do list. You need to know how to factor using the AC method and when it's appropriate to factor using the AC method. Excuse me again, and I will tell you that it's most appropriate to factor using the AC method when you have an A value. Here the A value is 12. When you have an A value that's greater than 1, then it's most appropriate to use the AC method. And I've already looked at this, and I approve of the language that's used here in terms of how to figure out the AC number by creating your factor pairs, as I call them in my video, identifying the factor pair that multiplies to equal your A value, or sorry, your AC value, which is negative 24. So negative 24 does indeed equal 3 times negative 8. We've used the 3 times negative 8 to split the middle term. Notice that 3x minus 8x equals negative 5x, which was our original b value. And after splitting that middle term, we now have a 4-termed polynomial, and we're going to factor by grouping. And it says factor by grouping. And on the to-do list I gave you, in addition to factoring by the AC method, the subtopic was factoring by grouping. You need to make sure you know how to factor by grouping. If you're not sure, or you're not great at factoring by grouping, turning this stuff into this stuff, then you could look around in the rest of this section for additional information on factoring by grouping. You can see if there's a subtopic listed here. I'm not seeing it specifically, so maybe it's in a previous section, or maybe you need to go up here and run a search for factoring by grouping. I love that when I get a search result that matches 100%. Greatest common factor and factoring by grouping. I've clicked that link. Sure enough, it took me into the previous chapter section, 4.5. There's factoring out a GCF, factoring out a negative, and finally factoring by grouping. You could just scroll down to get to that subtopic, or if you just click on it, it takes you all the way down to subsection 4, factoring by grouping. Here's the written out example. Here are the steps involved. Here's an actual example with all the articulation and annotation on the right-hand side. Mistakes to avoid, that's nice. Another practice problem where you already have it in 4 terms. The answer that you can get by hovering, and a link to the publisher's provided video. Or, as another option, now that you know that you're in Chapter 4, Section 5, you can come over to my list of videos. We were already in Chapter 4, and sure enough, 4.5 is my 27 and 58 second video on factoring out a GCF and factoring by grouping. So even if you just go into this video to find some additional example problems, I mean, look at this thing. That's pretty complicated looking, and this one's even more complicated looking. So if you want maybe some more challenging examples, you can pop into here and practice some additional factoring by grouping, or at least see how to get those problems started. All right, I think that's enough. So this trinomial that's up here does not have a leading coefficient larger than 1. This says 1w squared. So how am I supposed to factor an expression, a numerator like that, that has a leading coefficient of 1? I'm going to come back into my table of contents. I'll go down to chapter 4, which seems to be the one that contains all of the topics that are about factoring. I'm going to go back into factoring trinomials because that numerator was indeed a trinomial. And let's see, this has the AC method in it. Could I still use the AC method in order to factor if there's an A value of 1? You sure could, because finding the product A times C would simply have an A value of 1, and you can create your AC number and still go through this process in order to get your factored trinomial in the form of a binomial times a binomial. So that's very reasonable to do it that way. Subsection 2 here talks about factoring using the trial and error method, and that's another possibility. I don't love it because it's time consuming. The AC method, even though it's time consuming, at least I know exactly how much time it's going to take pretty much every single time. And I'm not seeing an example here where they're factoring a trinomial that starts with a leading coefficient of 1. So instead of being in chapter 4, subsection 6, or just, I should say, section 6, let me come back out here and see greatest common factor, factoring by grouping, factoring trinomials. I'm not seeing an example with a leading coefficient of 1. Maybe I'll come back over into these videos and see. This is GCF factoring trinomials. Maybe I did an example. This is all about factoring using the AC method. We can just hop through this video a little bit and see if we can find an example problem with a leading coefficient of 1. And boy, all of these problems look pretty challenging, and I'm not seeing leading coefficients of 1, unfortunately. So you might have to do some additional exploration in order to find an example problem with a leading coefficient of 1, or use the AC method on this problem. But I know that the solution to factoring that numerator is going to result in a pair of binomials. I'm thinking about the reverse foiling process. So as I FOIL this out, my first term is going to be a w, so the w times w gives me w squared. I know that my last term in each binomial is going to have to either be a positive 4 and a negative 5, or a negative 4 and a positive 5, because, well, I guess it doesn't have to be those, but I know that this number times this number need to multiply to negative 20. Imagine foiling this out. The L in the foiling process would be 4 times negative 5, and that would give me the negative 20, so that works. But if you FOIL this out, the two middle terms, the O and the I terms that result from the foiling process, in this case are going to be a positive 4w and a negative 5w, and when I add those together, I would get a negative w, which is incorrect. So if I switch the sign on these two terms, this is sort of the trial and error process. If you FOIL this out, you'll have a negative 4w plus 5w, and when you combine those like terms, you will get this positive w right here. The difference of squares process will end up yielding a w minus 4 and a w plus 4. And then you can see the canceling or simplifying that would happen here. Much easier now that it's in factored form. and your final answer will be w plus 5 over negative 5 times w plus 4. This negative sign that's in front of the 5 can be in the denominator. I could elect to just move it up into the numerator if I wanted to. I don't know why I would move it up there, but I could if I wanted to. Or I could put it immediately to the left of my division symbol, my fraction bar there, and that is allowed also. Those are all equivalent. Again, the negative sign can stay in the denominator. It can come up here next to the fraction bar, or I could push it into the numerator if I wanted to. So this is just one problem, but what it's allowed me to talk to you about and allowed you to review is a difference of squares, factoring out a common factor, a GCF out of the denominator. It allowed us to, can I Control Z my way back all the way into this? I think I can. There we go. I can even keep going, hopefully. So let's do it in order. We factored out a negative from this denominator, which allowed us to write these two terms in reverse order. Then we factored out the GCF, which was 5. That's how we got this 5. That made it more clear that we were working with a difference of squares. We talked about factoring a difference of squares, which was on our to-do list. And then in the numerator, we did end up having a conversation about factoring using the AC method. And we saw where that resource was located in the ebook and in my lecture videos on my YouTube channel. And then we did a little bit of trial and error in terms of factoring this numerator and getting this numerator in its factored form. Instead of actually using the AC method, we just sort of did a little guess and check in order to get the 4 and the 5 in here. That was serendipitous. I could have started with a -1 and a +20. -1 times +20, that equals -20. Except -1 and +20 are too far away from each other to add them together to get a +1w here in the middle, which is why I sort of intuitively started with a 4 and a 5 in these two positions. I had the signs wrong, and then I ended up correcting them to make this a -4 and a +5. So just one problem allowed us to do a lot of review, or to review a lot of topics that are necessary. I'm not going to go through that entire process for the remaining topics that are here in Chapter 5, but let's talk about what else we might need to address. Here's another denominator that needs to be factored. But this question is about the domain. So you'll need to factor this denominator, set it equal to 0, and determine the x values that would cause this denominator to equal 0. And then we want to find the x values that are not in the domain. So in this case, +4 and +1 are x values that you would, I think it's +4 and +1, that you would not want to be in your domain. Sometimes we list a domain as a list of x values that we want to use. In this case, it's very specifically asking what x values are not in that domain. Let me just think for one moment, because it's still morning, so my head's not fully into math mode. This denominator would factor into x minus 4 times x minus 1. So +4 and +1 are indeed the x values that we don't want to include in the domain. Domain of rational functions, right? Come back into here and see what you can find. Now, it's not in Chapter 4, which is what these videos are, but we're not actually reviewing for Chapter 4. We're reviewing for Chapter 5. So can I quickly get back to...
Multiple of 2. Taking an expression like this one and turning it into the product.
Let me hear me on 1.5 speed. And, Chapter 5, there we go. Let's view the full playlist. Rational expressions, rational functions, multiplication, division, add, subtract, complex fraction. Okay, so it's not blatantly obvious which one of these sections we need to be in, so should probably pop over to here. go into Chapter 5 and see if we can get some insight into which section we need to be in. Rational expressions and rational functions. I mean, that is what we're looking at in this practice problem. This is a rational function. It's a function, and this is a fraction, which is the rational part. So that might actually be where we need to be. Hey, these things look familiar. See how this is a matching game, right? These functions look a lot like the function that I'm working on in this practice problem. So I'm probably in the correct chapter and section in my ebook, which is 5.1. Simplifying ratios of -1. That's another thing that you really need to look at in order to be successful on this Chapter 5 test. Now, these are resources you've had all along, so the fact that I'm having this conversation with you now is a little surprising. I shouldn't be having to have this conversation with you because you're aware of all these resources, and I have encouraged you to use these resources all along. I'm not trying to sound like a jerk right now. I'm just saying, right? These have been at your disposal all the while. So, review a little bit about domain of rational functions. We've worked on problems like this in class. This was in a lecture activity in class. In this fraction, notice that the numerator and denominator here look like they're written in reverse order, swapped around this minus sign. We can keep the numerator the same, 6 minus 5u, in the u word. It's not letting me type the letter u. That's weird. I get an X. I cannot. It knows that I'm not actually supposed to be typing letters. There's not actually going to be a letter in my correct final answer. But I could leave the numerator as 6 minus 5u, and then this denominator, if I factor out a negative, I can change the order of these two terms and write it as 6 minus 5u. That was supposed to be in parentheses. It's not letting me type parentheses because it knows that my final answer is not even supposed to include parentheses. I apologize. That's not a very great place for me to type in an example problem. But similar to what we did in the previous problem, if you factor out a negative and then put this stuff in reverse order in parentheses, then the numerator and denominator will be the same. You can cancel those out and you're left with 1 over -1, leaving you with a final answer here of -1. Again, we talked about that in class, and you can go into the ebook, Simplifying Ratios of -1. It drops you into the third subsection, and here's an example of what I was just trying to type in to that review problem, factoring out the -1. They did it in the numerator in order to switch the order around of the terms that were previously in the numerator. Look, this says 2 minus x, and after factoring out the -1, it says x minus 2, so that the x minus 2's can cancel, leaving you with -1 over +1, which simplifies to -1. That -1, this -1, same -1. So please make sure that you know how to simplify rational expressions or fractions that involve factoring out a -1. So you need to be marching through all of these tiles. Here's another simplify your answer as much as possible. If it can't be simplified, oh no, sorry, this is just evaluate. This says f of 3. We need to take the 3, replace this x with a 3, replace this x with a 3, replace this x with a 3, do the arithmetic, get an answer, type that answer in here. And we already chatted about this one, simplifying the 3y minus 8s and reducing the 40 over 5. And then we're into 5.2. Right now it's time to march through these tiles. Division of rational expressions. Chapter 5, my videos, multiplication and division of rational expressions. In the ebook, Chapter 5, 5.2, multiplication and division of rational expressions. My videos, 5.2, multiplication and division of rational expressions. I really did make a concerted effort to try to have all of this stuff match up for you so that all of these resources aligned and were consistent you know, across the board between my videos and the ebook and ebook videos, multiplying rational expressions. Okay, example problems, practice problem that you can do, hover in order to find the simplified answer. Okay, that's multiplying. Dividing rational expressions. This is so funny that this is obviously an old image. See how as we zoom in on it, it gets all pixelated? But this part is the new part. So these are like vectorized images so that as you zoom in, they stay true and legible. But this is just old stuff that they grabbed and like copy and pasted it in like as a screenshot or something. It's kind of funny. Anyway, this fraction, division symbol. Identical stuff here. This fraction, they kept it the same. This symbol, they changed it to multiplication. This fraction, they flipped it to the reciprocal. See where I'm going with this? Keep, change, flip. This is KCF. We've done this in class. You've seen this before. I'd be willing to bet that it's in my video that's over here. And that's the rhythm, y'all. That's the name of the game. That's what successful review looks like. The only thing that I'm not actually doing in this video is I'm not actually doing these problems. You need to be doing these problems. And after using the resources that we've been looking at, my videos, your maybe class notes or other notes that you've taken on my videos or some other videos or the publisher videos, I'm just sitting on the lanai with bedhead. This is how raw I am with you. Please, in addition to going through and reviewing these topics and finding them in the ebooks and watching my videos and how I solve these problems, I also then need you to practice these problems as though you're taking the actual test. After you've reviewed the process, try to solve the problems without using any aids. Don't use notes, don't use videos, don't use practice problems that you have alongside of the piece of paper that you're using in order to work out a practice problem. If this is the problem that you're doing, try to factor this difference of squares on your own. Try to use the AC method on your own in order to factor this trinomial. All right? Do the keep, change, flip on your own, because when you take the test, you're not going to have any assistance alongside of you. And I'm not going to put difference of cubes and difference of squares and factoring out a -1 up on the overhead again during the test. You need to have those patterns memorized. And please make sure wherever it is that you need to go into the ebook or go into my videos, figure out those patterns. You need to know what those look like in order to do successful factoring so that you can simplify these rational expressions that are involved in this chapter. All right, that's it. That's my video for the day. Be prepared, because I definitely want to see massive improvement in your Chapter 5 test scores. I think you can do it, but obviously it's going to take you some time marching through all those topics in all those sections of Chapter 5, including referring back to Chapter 4 for some assistance with factoring. Good luck on your review. Do practice problems without assistance next to you. Okay, that's the name of the game. That's what's going to happen on the retake. See you Tuesday after Thanksgiving.